Okay, good day students. How are you all? It's been quite some time we didn't meet due to this COVID MCO holidays. Of course, we have been giving you some homework regarding the chapters that you have done on the force. And for today, what I intend to do is we have to skip chapter 3. It's also about force, but it's a universal gas gravity law. Okay, so those chapters are a bit abstract, so I decided to teach them in person in class. Okay, because this chapter, the two chapters, it's a completely new chapter for your syllabus. It's unlike the old syllabus. So what I did is trying to do is we try to catch up with those chapters once the school reopens. Okay, but this chapter, this is chapter 4, heat. It's a bit easier chapter to catch up with. So I decided to do a clip with your PDP. So it's going to be a series of lessons with you all regarding this chapter. For today, it's going to be a rather short lesson because it's just an introduction. So what I plan to do is just introduce you to this chapter, and our mode of teaching will be please, I have already uploaded your notes regarding this chapter in your Google Drive, and also shared the notes in Telegram. So you can use either mode. If possible, please print out those notes. And while I'm teaching, I hope you will refer the notes as well and see my teaching. Then we can get a better understanding. As you all know that physics is a subject whereby you need to understand the concept, the ideas, before we try to do problems regarding this chapter or any chapter for the matter. So what I want you to do is please print out the notes, and I'm going to go in the normal mode. You can say it's fast also, but since it is recorded, so you can review again and again. Any idea that you don't understand, you can see again whatever I'm teaching together with notes. So hopefully you can get a better understanding by the end of the lesson. Okay, so for today, it's going to be a series of lessons. So today is going to be Form 4 PDP part 1 on chapter 4 heat. Okay, what we are going to do is we are going to learn some concepts in this chapter. So what I intend to do is, this is a conceptual map. This is not in the notes, the printed notes which I uploaded in your Telegram and also in GC. It's not there. So later you can copy this and view it. So these are the concepts that you are going to learn in this chapter. Okay. One is thermal equilibrium, the first part we are going to cover today. Then specific heat, is about heat. And then finally it's about gas law. Alright. So what I want you to do is, please refer the notes as well. Okay. So for the first part we are going to see thermal equilibrium for today. It's going to be a very short section, but it's rather important. Okay. In the first place, why this heat is so important for us? Because if we look at the energy part, which physics mainly dealing with physics, mainly dealing with heat and energy and forces. Okay, so one of the very important energy is heat energy. Okay, in fact, without heat energy, I don't think this world can exist. All right, so everywhere you can see the point of heat in daily life. All right, so what we are going to do is we are going to quantify this heat, how we are going to measure the heat. These are the ideas you have to know, right? How to find the temperature of a substance. Okay, how we measure heat. Okay, to measure heat, we have to know two things. Number one, heat you must know is a form of energy. Alright, it's a form of energy. The second part you have to know is what is related to the heat is the temperature. Alright, if you look, refer the notes. Okay, if you refer the notes, they already explained the concept in detail here. So heat, if it's defined here, is a form of energy. It's a form of energy which move from higher temperature to lower temperature. Okay, that means we have to talk about what is temperature then. Okay, temperature is basically a degree of hotness. That means if let's say I want to measure something, I want to know how hot the substance is. It's, in fact, it's rather relative, right? If the one temperature is higher than the other, then you can say it is hot. If one temperature is lower than the other, it is cold. But again, as I said, it's relative to your body. Your body temperature is about 37 degrees Celsius. Let's say you touch something. For example, I touch this marker pen. I feel a bit cold. That means the temperature of this marker pen is low and my body temperature is high. So what happens is that the heat from my body, heat energy from my body, which is higher temperature, goes to the marker pen, which is lower temperature. So the heat is being absorbed from my body to the marker pen, so I feel it is cold. Suppose I put this marker pen in the fire, right, for a couple of minutes, then I take out, then I touch, I feel this marker pen is hot now. That means the temperature of marker pen is higher than my body temperature. Therefore, the heat from the marker pen flows to my body. So when this happens, I feel it is hot. So cold or hot is actually relative to your body temperature. So whatever it is an indicator for us, easy for reference, to say what is the temperature of our body to relate whether it is hot or cold. So basically, temperature is, in SPM they ask, what is temperature? You just have to mention it's a degree of hotness. Alright, it's a degree of hotness, and usually we have many scales to measure the temperature. Okay, so usually we measure the temperature in degrees Celsius. We also measure in Kelvin, alright, in Kelvin, which is SI unit. Alright, this is a non-SI unit. Of course, there's another not very popular temperature scale. It's called Fahrenheit. Alright, we mark with right, Fahrenheit. The American, they like to use Fahrenheit. So in fact, you can convert from one to another, okay, from one temperature scale to another temperature scale by using some conversion factors. Alright, okay, so temperature means degree of hotness, simple as that. Whereas heat is a form of energy which flow from higher temperature to lower temperature. That means heat actually doesn't stay in one place. Okay, it is a form of energy which is always on the move. It means whenever the object is any object for the matter, if you take it contains heat. Our body contains heat. Right? If I touch anything, the minute I touch anything, either heat from my body will go to that object, or from heat from that object comes to my body. It's all depend on the degree of hotness, the temperature. So therefore, heat is a form of energy. So therefore, since energy, so we measure this by joule. It's a SI unit, alright. Of course, you all also learn in biology, alright, or when you learn study about food. Every food gives out energy, but those energy we also measure by in the unit of calorie. So food energy usually, the content of heat energy in the food we usually measure by unit of calorie. Right? There is a relationship, of course. Calorie, right? So we can say it's about, I think it's about 4.2 joules. It's equivalent to about 1 calorie. Right? So you got to check with that. So it is just a conversion of unit. We always like to mention heat content or energy content in food in terms of calorie. Alright, how much heat energy it gives out. So these are two concepts that you have to know. So in this first part, these are the two concepts you are going to see, heat and temperature. So heat is a form of energy which is derived from higher temperature to lower temperature, as you can see here. Heat is transferred from hotter object, higher temperature to colder object. So in SPM, you ask what is heat? You just have to say heat is a form of energy which flow from higher temperature to lower temperature. Okay. So is it going to flow forever? Let's say I touch this marker pen. The heat from this marker pen, suppose, is lower temperature, and my body is higher temperature. So the heat from the marker pen flows to my body, right? So when it flows, is it going to flow for forever? Definitely not. Definitely not. After some time you hold the marker pen. First maybe you feel cold. It's metal, you feel cold. But after some time you don't feel anything already. That means object A when in contact with object B. So when we say this is internal contact, the minute internal contact, that means the heat is start flowing from both the object. Alright, just now it's not in thermal contact, now in thermal contact. So the minute in thermal contact, if there is temperature, theta 1, I call this theta 2. So if the theta 2, theta 1 is more than theta 2, that means more heat over here, the temperature is higher, A is lower, so the heat from here is going to flow from here. So after some time, these both objects will have the same temperature. Alright, will have the same temperature. Let's say theta 3. Theta 3. Both will have the same temperature. That means they already reach a point called thermal equilibrium. It reached a point called thermal equilibrium. That means after some time, after I touch, I don't feel anything already. Okay? That means the marker pen and my body now has reached thermal equilibrium, which means both the temperature of my hand and the marker pen now is the same. Alright, so therefore it reached thermal equilibrium. Okay, this concept of thermal equilibrium is very, very important, because using this idea of thermal equilibrium, scientists have designed thermometer. Okay, thermometer is used for what? Thermometer is used to measure temperature. We have various type of thermometers. Alright, the most common, of course, you use in the school is the one you use, the mercury thermometer. Alright, mercury thermometer. We have other thermometers also, depend what you want to measure, what temperature, what range of temperature you want to measure. The normal temperature we use to measure with the thermometer is from about -10 to about 380 degrees Celsius, the mercury thermometer. So if you want to measure temperature out of this range, that means more than 380 and less than -10 or 0, then you have to use different kind of thermometer. Okay, so we won't be studying all those thermometers. In this chapter for your syllabus, we just focus on mercury thermometer. Alright, how the mercury thermometer works. So all the thermometer works based on thermal equilibrium concept. Thermal equilibrium concept. That means when I take the thermometer, I put in a glass of water. Right? So you see the temperature, let's say it's warm water, so the temperature starts to goes up. So after some time the temperature rises, it stops. The minute it stops, that means the thermometer has reached thermal equilibrium with the glass of water. That means whatever the temperature of the water is the temperature that you can reach, because no more net heat flow. So when the object reach thermal equilibrium, that means the net heat flow. Take note that net heat flow is equal to 0. Net. That means, is the heat flowing? Yes, heat is flowing. That means maybe 50 joule of energy going here and 50 joule of energy is going there. So when these two energy goes from here to here, the same amount, that means there is no more net heat flow. If initially here it is moving 70 joule and here is going 20 joule, that means net heat 20 joule is flowing here. So after some time, when there is the thermal equilibrium, there is no more net heat flow. That means the amount of heat which is flowing in and out of both the object in thermal contact is the same. So therefore we say net heat flow is 0. So when the net heat flow is 0, temperature of both the object is the same. Got it? Alright. So when there is a two different objects with two different temperature, when you put in thermal contact, heat start to flow. After heat start to flow, after some time it will reach thermal equilibrium, a state whereby amount of energy given out and the amount of energy received become the same. So we say the object has reached thermal equilibrium. In other words, both have same temperature. So this concept we like to ask, what is thermometer, temperature, what is heat, what is thermal equilibrium. So please know that things all there in your notes, okay? So you can refer back, okay? So now we are going to see, have you ever wondered how the thermometer is made? Let's say you have a thermometer, then you put, you see the thermometer got number, -10 or sometimes start from 0 to 100. How do they mark the numbers on the thermometer scale? Is it they simply make a glass, put in some mercury in it and just mark it with ruler? Definitely not, it's not the way, okay? So what they do, so the next section we are going to see the application of thermal equilibrium. That's the first section in your notes, okay, whereby how the concept of thermal equilibrium is used to make thermometer. So for that, what they do, okay, how do we refer temperature then? So as you know, scientists, they always like to get something, some reference which is absolute, that means which is ever existing, we can use it as a reference. Like for example, when you say sea level means there's a zero altitude, okay. So any altitude that you measure from the land is always referred to the sea level, because sea level we assume as a zero altitude. So if you take like Mount Everest, 8,086 meter. So how do you get that? Okay, that's from the sea level. So similarly, when you say 0 degrees Celsius, when you say 100 degrees Celsius or whatever temperature, we always like to refer something that exists naturally as a reference. So what did scientists decided is, okay, they say, okay, if I take ice, anything that you see in the form of ice, that means it will have 0 degrees Celsius. Then the same ice, when you heat it up and when it starts boiling and it's continuously boiled, then water, if you take water, when you heat up the ice, it will eventually turn into water. So I say boiling water, the temperature is 100. So these are the two reference points scientists use to make the thermometer scale, the calibration. Alright? So what they do first, they take a thermometer, okay, all this in your notes, they place it in the ice. Alright, they place it in ice. Alright, this thermometer, then they leave it for a while until it reaches thermal equilibrium. That means once it reaches the thermal equilibrium, the mercury will start to drop and stop at one point. Alright, when you stop at one particular point, okay, when you use one particular point, let's say stop here. So after some time, there's no more movement of this mercury level. So I indicate this as 0. Alright, and when I take it out, alright, since mercury length changes in the thermometer, alright, so in the capillary tube inside, so whatever height just now I attained, I indicate this as 0 degrees Celsius, and I also take from the neck as the length L0. So I call the length L0 is actually 0 degrees Celsius for this. Any thermometer you can make it any size, right? You just have to put it into the ice. So the first reference point I got already, that is L0 is for 0 degrees Celsius. So what I do next? Next I go for the standard reference point, boiling point. What I do now I take up a round bottom flask. Alright, round bottom flask. The neck here, right? Okay, over here I place the same thermometer. And I heat up the water. Alright? So what I get here is steam. Alright? Boiling water steam, I don't enter it. Okay? If I enter it, maybe you'll get a different temperature. It depends on is there any ingredient or what. So water boils purely at 100 degrees Celsius. We say that, right? 100 degrees Celsius means it's a boiling water, pure water. So let's say now the mercury level, after some time, of course the mercury will go up and stop here. Alright, when it stops there, okay, here is the steam is coming out. Alright, so this is called as boiling point, 100 degrees Celsius. And I take now, just now I already marked here 0. So now from here to here, I mark it as L100. The length is L100 from here to here. Okay. So these are the two reference points that we got already. Naturally we got that. That means you take a blank thermometer without scale, you put it into the ice, after some time you mark after it's a thermometer you mark it, then the same you mark here. So you got two different points already. Okay, so now what I do, I get a glass, a beaker of warm water, Alright, now I place the thermometer here. Alright, thermometer here. And it reached thermal equilibrium. Right? This is a warm water. Right, so just a warm water. So let's say it reached thermometer, the equilibrium. Just now I already indicate 0. Here I indicate 100. So now it reaches here after thermal equilibrium. So I want to know what is the temperature here. And from the neck of the mercury, the bulb, the length is, let's say, L theta. So now I have to make the scale already. That means from here to here I have to divide equally 100 segments. So each segment will be stand for 1 degree Celsius. So to get this L naught, so how to mark them equally? So we use the calibration. So what we do here, we take, alright, theta degree Celsius is given by, you take the length L naught, you take the difference from the 0 degree Celsius, the length, and then you divide by the difference from 0 to 100. This is the difference of 0 to 100. Then you multiply by 100 degrees Celsius. Okay. So this is how the scale is made. Alright. So any length you get it, you want to know the temperature? Very simple. Take the L theta. Sorry, here L theta. Yeah. L theta, L0, L100 minus L0 times 100 degrees Celsius. So therefore, this is the first formula that you learn for thermometer. So this is how the thermometer scale is being made. So there are many thermometers which I don't want to discuss, right? Because it's not in the syllabus. So this is a basic thing, okay? But any thermometer they make also, still they go for these two reference points, ice point and steam point, the boiling point, right? These are the two difference they use to make the thermometer scale. So please remember the formula. Any temperature you want to make, you find, you use L theta minus L naught divided by, this is for mercury thermometer as shown over here. Alright. So all this is already you can find in page 63. Alright? Yeah. Page 62. Yeah, page 61 they explain about the idea that I just discussed. In page 63, in fact, they have the diagram and the notes there explaining that. And the formula also is there. The formula also is there for you. Alright? So you can refer your notes and questions. Okay, I just give you one example. So later, after learning the second concept, I give you a few more questions. Maybe I'll upload some questions on this for you, so you can try out. Okay. Okay. Let's say when you put a thermometer in the ice, the length. So you have to make L0. The length, let's say, is 5 centimeter. After you place in boiling, so let's say the length is 30 centimeter. Example. Now when you place in the warm water here, let's say the length for theta is become 15 centimeter. So I want to know this 15 centimeter length is equivalent to how many degrees Celsius. So what I do, I just use the formula. Theta degrees Celsius is equal to 15 minus L theta minus L0, 5 divided by 100 is 30. L100 is 30 minus L0 is 5, so times by 100 degrees Celsius. Okay? So 15 minus 5 is 10. This is 25 times by 100 degrees Celsius. So cancel 4, so we get 40 degrees Celsius. That means the temperature of the water is 40 degrees Celsius. So this is how you do the solution for application of thermal equilibrium concept using a thermometer. Right? So that's the part we are covering here for today. So please refer your notes from page 60 to 62. It's all there in detail. Okay, and then one last part they discuss is how to increase the sensitivity of a thermometer and why they choose mercury. Okay, it's already explained here. The purpose of choosing mercury, why we don't want to use water, why we don't want to use other liquids. We use mercury because number one, mercury is a good conductor. You know, mercury at room temperature is in liquid form. Alright. So number 2, it has a very high boiling point, 357, which is good enough for us to measure any practical temperature around us. And number 3, it expands uniformly. That means every time when you heat, the temperature goes up, the length is uniform. That means from 0 to 1, 1 to 2, 2 to 3, it uniforms, it expands uniformly. Then number 4, it is opaque. That means you can see through it. Alright. So it does not allow light to pass through. Right? It's not transparent. So opaque, so you can see wherever the mercury stands. Alright. And so these are the 4 important points why we use mercury as a liquid in the thermometer. We don't use water. Alright. And then how you want to increase the sensitivity, or you want to make it like, for example, you want to make a thermometer, clinical thermometer. Clinical thermometer, usually the range is from 32, maybe 32 to 40, 45 the most. Alright, because after 45 human being cannot live already, right? So the range, the temperature. So we can make up to in 1 decimal place. Alright, so you want to increase the sensitivity, you want to make it longer. So what we do, we make a thin capillary here. The thin bulb. That means the glass is very thin. The minute it touches, it absorbs the heat and the temperature goes up. If you make the glass too thick, then it takes very long time to heat to get transferred to the mercury. Right? So it must be a thin bulb. Right? Number 2, you must have a very fine capillary tube, and then the bulb must be large enough to have to absorb the heat as much as it can. Right? So remember, how long you put also, after it reaches thermal equilibrium, the temperature won't go up. That's the main idea over here. So with that, a short lesson for today, I stop. Then from the next lesson, we will go into more abstract concepts, heat capacity, latent heat and all that. So please know this idea of thermometer, thermal equilibrium, temperature, heat. Okay, these are the 3 concepts, and how these 3 concepts is applied in a thermometer to measure temperature. Right? So that's the lesson that I'm going to have today for you all. So please look back at my clip and also refer the notes. I'm sure you can understand better. I will pose some questions on the application of this formula for you. So please bear with us. Alright. Please take care of yourself, follow all the rules of MCO, alright, don't simply go out, take care of your health, alright, hopefully we can meet up soon once the school reopens, and bear with us, alright. So I'll make up the second clip when you come to another couple of days, after you go through these notes and understand the questions. So in another few days time, I'll make the second clip to teach another concept, right? So till then, we'll meet up. Thank you very much and good luck. So have a nice day. Thank you.